11-year sun cycles. C2 equals E divided by M. This equation, C2 equals E divided by M, completes the physics trilogy for mass, energy, and time. C2 describes the field of time, or that of gravity. In that gravity performs work, it has to have an energy source, and that's what we're going to examine. The energy source for our gravitational field that exists within the sun as well as our planet. I'm going to ask 4 questions and then give an answer to them. And in asking these 4 questions, you'll understand why a field of gravity exists and why it is actually a variable. First, what would happen if there were to be an increase of heat energy within our sun? If our sun were to be hotter due to a sudden thermal burst within it. This represents our sun, this represents the thermal burst, and this represents what would happen. The gravitational lines are extended, meaning that the field of gravity about our sun would increase. If the field of gravity about our sun would increase, or it would increase due to a greater energy to mass ratio, the greater the energy to mass ratio, the greater or the more intense the field of gravity becomes. Now, number 2, what would happen if all the heat energy within our sun were to vanish? Here's our sun. This represents the heat energy, and the answer is our sun would have no gravitational field about it. If there were to be a planet the size of Earth, and if it had no heat energy within, it would have no field of gravity. It could be affected by gravity, but it would not affect another mass. There would be no gravitational field about our sun because there would exist no energy, E, to form it. As energy within a mass decreases, so does the field of gravity. Third, what would happen if the mass of our sun were to increase? Supposing a planet like Jupiter, a mass that large, fell into our sun, what would happen? There's our sun, another mass, and the answer. It's the same as if energy increases. And here's the reason. There would be an increase of gravity. Greater mass would cause the overall density of our sun to increase due to greater mass being drawn downward toward its center. This in turn would compress the existing mass, heating it to a greater extent, causing an increase of gravity. Fourth, what would happen if great amounts of mass were to vanish from our sun? And this is where it becomes interesting. Here's our sun. If mass were to vanish, notice these lines become very short. Because of an increase of sunspot energy, averages moving upward, it appears our sun could be headed toward becoming a nova. It's a strange thought. This is as when a major mass energy release begins, similar to earth tremors leading to a major earthquake. Were this to happen, then our sun would assume a new gravitational constant. This would necessitate our planet to establish a new relationship to the sun's new gravitational constant. During this period of adjustment, all the planets would be oscillating closer and further from the sun as they adjusted to it. That is because C2 equals E divided by M. The gravitational force would increase and decrease in the adjustment, and the planets moving about the sun would have to assume a new orbit. This is similar to our condition at present, mass vanishing from the sun. Our sun is continually losing mass. by reason of radiant energy and loss of atomic particles that form our solar wind, and the dissipation of its field of gravity, this being 665 pounds a second, and mass being converted to gravitational waves. And what does this loss of mass mean? As an increase of mass causes an increase of field of gravity, the decrease of mass causes a decrease of this force. As the pressure of surrounding mass within our sun diminishes, the mass surrounding the greatest gravity value must also decrease in density. It does this by moving outward from the center of our sun. As it moves outward due to a diminished gravitational field, the mass carries with it internal heat energy, cooling the interior of the sun just a little. It is this energy rising to the sun's surface in a burst of sudden adjustment of intensity that gives rise to sunspots. Every 11 years, our sun forms a new energy baseline, where there is an energy to mass gravitational balance, when there exists a period of solar rest. After a lapse of quiet years, there forms a new adjustment of mass. Excess energy once again is released, and the cycle begins anew. Our sun is in a condition where as energy is released from it in form of mass, or mass is released in form of energy, those two work together, as you well know, that there has to be adjustment for this lack of downward pressure. This downward pressure causes the heat energy within our sun to form. And if there is less downward pressure, there has to be an adjustment. And that's why the 11-year cycle exists. And it looks like that there could be a major adjustment, a major new baseline. And if this is true, then it is possible that our sun could turn into a nova. Lastly, the Bible speaks about this. It says in the last days that the sun is going to become very bright, and it's going to scorch the people. It's going to burn up all the grass and burn 1/3 of the trees. Is it going to happen? It is going to happen.